Today we are going to solve 4 previous SOA questions related to the topics of this chapter. Those are from textbook on page 25, questions 1.17 to 1.20. Obviously, those are the ultimate goal of taking this course. You don't need to pass the SOA to get the course credit, but of course, if you are majoring in actuarial science, it's recommended to take SOA exams once you finish the related materials. This is part of the SOA financial math exam. They are later on courses to complete the exam syllabus. So here, it's like the initial start of the journey. I will give you 1 minute to read the first question. Okay, now let's interpret the important information from this question. So here we have 2 people or 2 persons, Bruce and Lobby, each open up a new account at time 0. Bruce deposits $100 into his bank account. Lobby deposits 50 into his. Each account earns an annual effective discount rate. So here is discount rate. The amount of interest earned in Bruce's account during the 11th year is equal to X. The amount of interest earned in Lobby's account during the 17th year is also equal to X. Calculate X. So here we have some information, right? As I always say, at the beginning, it's always a good idea to draw the timeline. Here we have 2 people, so we have 2. So let's focus on Bruce first. It does not need to you don't need to draw the timeline exactly to the scale. It's rather show you the idea. At 0, it's $100. What we know is in the 11th year, so it doesn't matter. So let's say here is 10, here's 11. So this is the 11th year. What do I know? I know the amount of interest earned in this year is X. So now the question is, how do I calculate the amount of interest for Bruce in the 11th year, given that I know the effective discount rate is D? So obviously, we need to analyze the meaning of D first. What do we know from D, right? So from the review slides, we know that I'm going to use let's say I use the space here. Okay. So the meaning of D is, right? In my review, I mentioned it's a 1-year loan of unit dollar. If you pay interest at time 1, you pay I. If you pay interest at time 0, you pay D. That means D at time 0 will grow to I at time 1, right? So that is the meaning of D. So what is the accumulation factor once you know this is the annual discount rate is D? So if you take effective loan of amount 1 minus D, that eventually will become 1, right? So from there, we know the annual discount factor will be This is for 1 year. 1 divided by 1 minus d, right? So that is how you get the not annual, accumulated value factor, right? So in order to get AV1, in this case is 1 equals AV0 times the 1 plus I, right? So this is the standard way. But here what we know is my AV1 is 1, my AV0 is 1 minus d, right? So what is this, right? So from here we know 1 plus I is nothing but 1 divided by 1 minus d. So this is the analysis again. I did this one more time to connect d with I, right? So I know this is the 1 year discount factor. So this is 1 year. So now what is my AV at 10? So it will be my starting value, which is 100. Okay, so I need AV10. AV10 is simply raise the power to the 10th, right? Because here it's effective, so it's compound case. Okay, so that is my AV at 10. For the same reason, I can easily calculate my accumulated value for blues, not my blues accumulated value at the end of 11th year. Right? I mean, if you want, you can write it as divide. You can even treat this as a formula if you want. So in that sense, let me write down using a different color. So according to this analysis, my AVF t equals 1 plus I to the tth power, and it is also 1 divided by 1 minus d to the tth power. Okay, so you can even think that as a general formula, but you know my rule is don't memorize any formulas. Try understand everything, and once you understand, everything simply flows naturally, right? You don't need to actually memorize. So what is the interest? Interest is the actual amount of value changes, right? So my amount of interest would be the AV11 minus AV10. That would give me AV, I can take out the entire thing and 1, okay, minus, here is 1 minus d, right? So what I have is 100 times, this is d, divided by 1 minus d to the 11th. So I figured out the amount of interest earned in Blue's account during the 11th year, okay? So this is for Blue's. If that is already done, the case for lobby is pretty much the same, right? So now we do everything for lobby, right? And we want the interest earned in the 11th year. So for lobby, it would be AV17 minus AV16. So I don't even need to, it's not 50. So that's the initial amount lobby deposited is 50, and it's the same. Okay, so let's use a different color to emphasize, right? So basically, you know, this number 11 is the same as the end time 11. So here I'm looking at the end of year 17. So this must be 17 as well, according to the information. Those two, this and this, they should equal, right? So now we establish equation. So we have equation. According to the information, what Blues earns in the 11th year matches exactly what lobby earns in the 17th year, okay? Before we do anything, try to simplify. So let's try another color. Okay. So D will cross D, right? This becomes 2. Okay. And this will remain with 6. Okay. So in the end, what do we have? From here, I have 2 times 1 minus d to the 6 equals 1. That means 1 minus d equals 1 divided by 2 raised the power to 1 over 6. Right? That is 1 minus d. Okay. Eventually, my d is 1 minus 0.5 to the power of 1 over 6. Okay. If you have calculator, that should give you around 10.91%. So what I just did is somehow the standard analysis, right? Because I assume that you guys are at the beginning stage. This is how you solve this question using the standard way. Okay. So, but of course, I can give you a different idea. Now, okay, in the second method, we are trying to understand the real deal after everything. So now we have 2 people, right? They put different amount of money into the same account. Okay, by same account, I mean the interest rate or the discount rate is the same. The first person earns something in some year, and the second person earns the same amount but in a different year. Okay, we want to know the interest rate. Okay, D. Of course, after this, you should continue to calculate what is X. The question actually asks you X. So once you know D, you can plug in either one of those, right? So I leave that to you to finish. That is not the important thing. The most important thing is to calculate this D. Okay. Instead of doing everything, I simply claim this. Okay. In the second method. I claim that the accumulated value or the Blues account at the end of year 10 is the same as the account value of Lobis at the end of year 16. Right? That is the only case. Okay, I'm going to have the same interest for both people. Right? When you have the same, because when you have compound interest or for anything, right? Because we talk about 1 year. So let's say you have AV at time t, and we want to know how much interest you will earn in the next year. So in order to calculate this, so this is the AVT plus 1. I think that is clear to you, right? And the interest, okay, earned from t to t plus 1 is nothing but the difference. Right? Now, because both Blues and Lobby are going to earn at the same interest rate, because the discount rate is the same. Same discount rate means the same interest rate. If I is the same, the only case I will get the interest to be the same is the AV is the same. Of course, they are at a different time. So I'm talking about the 11th year for Blues and 17th year for Lobby. That means in the beginning of that year or by the end of the previous year, they should have exactly the same amount in their account, right? Then over the next year, they're going to earn the same interest. With that in mind, you can establish your. I can quickly establish everything. right? So this is quicker than me doing all the analysis, analyze the AV10, AV11 for blues, and calculate the difference to get the interest, and then do the same thing for lobby, and then I match them. It takes so much more time, right? And once you are out there taking SOA exams, time is the most important thing. In many cases, I do believe all of you can actually handle the SOA questions. Okay, the question, the somehow the challenge part is that whether you are able to handle most of the questions within the given time. So that's why eventually I'd like you to understand the second method. Okay, with the understanding from the second method, you can quickly solve this question because you can see this equation in one step. Oh, excuse me, here is 16, right? And from there, you can quickly see this is 0.5, okay? And the punch of calculator is quick, right? So once you get D, you're going to calculate the AV at 10 for blues and AV at 10 times I, okay? What is I? I is the future value of your D, right? So D equals I times V, right? So this is 1, right? So from there you can get the interest X. That is our first question. Let's move on to the next one. Let me move this to the next page. Okay, I give you 30 seconds to read the question. Okay, question 1.18 asks you the force of interest, right? So it's continuous interest, and it's rather difficult to type delta. So here, let me write down what is delta t. So it's 0.01 times t squared, and t is obviously greater than 0. So it's actually growing, right? As time moves further, the force of interest actually increases. So we are trying to calculate the amount of interest earned from time 3 to time 6 is x, and calculate x. So again, I always start with this timetable, timeline. At time 0, earning deposits $100, and another deposit at time 3. The fund grows at a force of interest, okay, that is given. The amount of interest earned from time 3 to time 6 is x. Okay, so that part we need to analyze. Okay, so since here we have 2 deposits, right? So the AV will have a jump or have a sudden increase at time 3, right? So let's do this. Okay, first we have AV0 equals 100. So we look at the first 3 years before the second deposit. Okay, so in that case, my only contribution is from the first deposit. So my initial deposit is 100. Okay, and since I have force of interest, so it will be exponential raised the power to the integral from 0 to 3, because I'm looking at 3, and it's going to be the force of interest dt, right? So that's nothing but definition. Okay, so that is the AV3 before my second deposit, right? So next, I deposit another at the 3. That means after that deposit, my new account value, I still use AV3, okay? will be the old one. Let's put a minus sign to denote that is before the deposit, and put plus to denote that's after. So that will be the account value before deposit and plus the amount I deposit, right? So if you want, you can do the calculation. From 0 to 3, 0.01 t square is, so here, okay? So when you have a power function, power goes up by 1, and you need to divide by the same power, 0.01 t from 0 to 3. So it's easy to see that the 0 will give me 0. So it's 3 over 3, so it's 0.09. Okay, keep that number. I don't need it at this moment. I just copy everything. 0.09 plus x. So this is the amount earnings account will show up at the end of year 3. Okay. Now, what information I have? I know from year 3 to year 6, I know the interest. Interest is x. Okay. Again, how do I calculate interest? I need to know how much her account is worth of at the end of year 10, year 6. That will be my AV3 times, again, is exponential, but now it's from 3 to 6. So basically, the lower point is the starting time. So here I start at AV3, so this is 3. I'm ending at 6 because I want to know the value at 6. For the same reason, if I start at 0, here is 0, right? And I want to know the value at 3, so the up point is 3. So that's by the definition of continuous interest rate. So for the same thing, I know this is 0.01 t squared dt. So I can copy. Now I do the same thing. It's still 0.00001 times t cubic divided by 3. But now my t value goes from 3 to 6. Okay. You need a little calculating from there. What I have is I can just keep AV3 right now. Okay. I do the second part. It will be 6 cubic minus 3 cubic, and the difference divided by 3. Okay, and then I'm going to times by 0.01. I like to keep everything in fractional, but it's your choice. Right? If you want to keep in decimal, that's fine. Okay. Finally, I can calculate the interest from t equals 3 to t equals 6. That will be my account value or earnings account value at time 6 minus her account value at time 3. So this will be, I can factor it out, times this exponential number minus 1. This equals x, right? Okay, now I have everything I possibly need. Okay, the next thing is basically to solve the equation, and let me show a little bit more details because this may not be easy for all of you. Okay, so this is my AV3 at the end of year 3 after the second deposit. This is how much earnings account will get times this number. So the positive exponential is greater than 1. So this minus 1 will be positive. Okay. So I'm going to solve this equation. To help me, I call this constant A. It's a constant. This is constant B. So now what I have A plus X times B equals X, right? So I can move everything with X to one side. So distribute. So it's AB equals X minus BX. Factor out X. It will give me 1 minus B times X. That means my X will be equal to A times B divided by 1 minus B. Okay, now let's put back what is A, what is B. A is 100 times e to 0.09 times e of 108 over 300 minus 1 divided by, so it will actually help a little with the computation. Okay, now it's time for you to hit the numbers to calculate. Okay, try. Getting familiar with your calculator is also an important step to pass the SOA exam. I give you this result. Okay, this is the final result. I do recommend you to do the computation in one step and get this number instead of writing down what is exponential of 0.09, what is exponential of this fraction number. Of course, at the beginning, you can do this and write down exactly what is A, what is B. For instance, B is about 0.8776. It is okay to do that, okay? That's because usually SOA has the option, say, between this, between that. So some minor, small roundings will not cause any issue. But from the point of saving time, it's more efficient to get everything done in one step. I will stop here for this video and continue for the next two questions.